Module 6, Section 1, Writing Tests. So let's now create some tests for our code. We can start with some unit tests in our types folder. If we go to our XRPS module, within our types we have the game object that we define many validation and useful functions. Let's write some tests for these ones. So we're going to create here a game test.go file. It's going to be within the package types tests. And we can start by testing the function isRoundRevealed. And we are going to use the testing package. Usually these tests are table-driven tests, so we can test many test cases in this unit tests. So we are going to define a test cases variable. It's going to be a struct, slice of struct with the name of the test case. Then we are going to have some player A moves that we'll define for each test case. Same for player B. And the expected result, if it is the round reveal or not, right? This is the expected result. And now inside here we'll define all the test cases. So we can start with some failing cases. For example, an even player moves count. And we'll define the player A moves to be a slice. And we are going to have, for example, rock here. Some other options, paper and scissors. And for player B, we are going to have an even moves, different number than the player A. So should be false, the expected, when we call the isRoundRevealed should be false in this case. The next case that we can add is a success case, where all are all valid moves. Success, valid moves, and we can say that these two have all these format. And we can add a couple of edge cases. Here we can add a failing case where we have invalid moves. For example, here we'll have an invalid. This is expected to be true because we want to isRoundRevealed in that case. And another edge case would be if it is empty, player A and player B have no moves at all, they should return true. It's an edge case. Should be true. Success. Empty moves. And now that we have our test cases, we have to run each of these. So we can do this so using a for loop in our test cases. And we can use this trun where we need to print the name of the test and a function that's going to have all the logic of our test. In this case, we'll have to create a game, types game, with player A modes that correspond to the test case. Same for player B. There we go. And now we can run the corresponding function that we want to test. Game is map reveal. Actually, we can just do this. Require equal to be the expected one to be the actual one. We can format this and run this test case. Fastest way to do this in VS Code, you can just click here and we'll run all your tests and give you the details if all are passing or not. In our case, you can see that all test cases are passing, so this is behaving as we are expecting. Now that you know how to write these unit tests, go ahead and write yourself some tests for the reveal player move and the add player move functions. Hope you managed to get the test done. Here I added the corresponding test for the add player move function. You will see that here to get some addresses, I'm using this test data package from the Cosmos SDK. That's quite useful to generate some keepers and use for our player addresses and other addresses for the different test cases. In my case, I defined a test case with this struct and defined all these success and fail test cases. Add a valid move with no previous moves. Add valid move with previous move revealed. Then try to add a valid move, but opponent's previous move not revealed. And many more if you want to go through them and make sure that you are at least covering these cases and more if you want. And the same for the reveal player move. Here I'm defining also the salt on the hash value and again the different addresses and then the different test cases for this function. Now that we have these unit tests for the games type, we can push this to our repo so you have it as a reference. Git checkout branch. We're going to put this into the lesson 6 branch. Git add. Git commit message. Add tests for game object. Add unit tests. Keep in mind that this is just some minimal test. You usually want to make sure you're covering all the different functions defined in the game object. But for our purpose, that is just learning how to write these tests, this is good enough. I'm going to push this to the lesson 6 to our origin. So now let's write some unit tests for our message and query services. For this, we will go to our keeper folder and add a new file called keeper-test.go. And in this case, for these tests, we will need to set up a testing suite where we will initialize our keeper to use in our message server and query server tests. So let's do that. We'll have a package keeper tests and we'll define a type keeper test suite. It's going to be a struct. That's going to be a suite, a testing suite. and it's going to have a context, an SDK context, a query, no, not that one. This is going to be SDK. It's going to have our context. Then we'll have a query client. That's going to be our types. And our keeper, type RPS module keeper. Message server as well. Types message server. We can put this together here. And then we're going to have an encoding config of type module test util test encoding config module test util. There we go. Let's separate this. There we go. And now that we have this defined, we'll have a function to set up this suite. This is going to be keeper test suite, setup test, and we are going to have the encoding config to be main test encoding config from RPS app module. And then we're going to have a key value store key types module. We need the module store key to initialize a context. So let's add the store types here. Store types are Cosmos SDK store types. And then a store service runtime new key value store service for a key. The test context is going to be, we're going to use the test util default context with db for our suite, the key, and as store types new transient store key, transient test. This is just for testing. Then we have the suite context. It's going to be the test context with header info. It's going to be an empty header for now. And now we can instantiate our keeper. That's going to be keeper new keeper with this encoding config codec encoding config transaction config address codec, the store service, and the authority is going to be the auth types, new module address for gov, the governance module basically is the authority. We need to import the auth types. types, it's going to be alt types. And we have our keeper instantiated. Then we'll set the params for testing. Set params set within our context, and we're going to use the default params. Our message server is going to be keeper new message server implementation using our keeper. First, query helper from base app, new query server test helper. It's going to have the suite context and the interface registry and register query service server with our query helper and the implementation using the keeper, and that's going to be query client types, new query client using the query helper. This is all the setup that we need for the moment, just setting up the params and the keeper so we can write our tests. And then we'll add here a function to run these tests. Test keeper test suite. And it's going to be type testing T here. And we'll run here suite run the keeper test suite. This is going to run all the tests that we are going to run to write within this test suite. So now that we have the setup, we can start writing tests. We can go here and create a new file for the message server tests.go. And here we're going to be in the package keeper test. And we can first test the message create game. And again, we're going to use table driven tests. Let's first define some player A and player B addresses. Player A, it's going to be test data key test. Same for player B. And then we'll have our test cases. It's going to be slice of a struct where we'll have the name of the test case, the request, that's going to be your types, message, create game. If there's an expected error, and expected error message, so we can validate each error, and expected game, what's the expected game that will have it, if this is successful or not. And then we'll have here our test cases. We can start with some simple case where there's an invalid creator of the game. So our request is going to have it's going to be of types message create game, and the creator, it's an invalid address. Then the opponent is going to be okay. It's going to be just a player A, player B string, and rounds, it's going to be valid rounds as well, just 3 rounds. expected error to be true, and the expected error message would be of types invalid address, so feel free to add here all the test cases that you want. For us, I'm going to just write here the logic for the test, so it's not too long the video, but I will add more test cases. So how we are going to check here all the tests, we're going to do a for loop, test cases, define it here locally, and we're going to run test case name and the function where we are going to set up the test, and then we are going to message server create game using the context of the suite and the test case request. And then if we are expecting an error, we will check for this. We'll use the s require error to be defined and check that the error contains the expected error message. Our error contains expected error message. Else the test should be successful, so no error. Require no error. Then we'll have to check that the game sequence should have increased. So the game ID, we pick up the game sequence, should be 1, so this should be have no errors, no error, and the game ID should be 1, equal game ID to be N64 1. Then we'll have to check that the game was stored successfully. And we'll query the state using our keeper games get the game ID, and this should have no errors, and this should equal the expected game to be the same as the game that we stored, and then check that the new game was added to the active games queue. We'll check that as well. So we can do something like this, where we look at the keeper active games queue as our recently created game that we can check using the collections, join, the expected game expiration height, and the game ID. And this should have no error, and we should have OK to be true because it's found. So require true for the OK. So this is all the checks that we're going to do for our test cases in our create game. For now, we only have this test case, but I'm going to add more test cases. Feel free to add all the ones that you can think of. And yeah, I will show you later which ones I added. I added here more test cases. We can go through them. I added an invalid opponent test case. Invalid opponent, that's the same as the creator. This should not happen. This one actually is passing at the moment because we are not checking that the address, it's a bec32 address, but it's from another chain. We'll have to add a validation for this to avoid having addresses from other chains being stored within our game. We'll fix that in a moment. Then creation with rounds more than the max rounds allowed, with rounds equals to 0, and then a successful case where we can create the game successfully. So let's fix this check for the player. So this check, if you remember, it's done in the game object, in the game.go, where we get the player name address down here. We're checking that it's an account address from bec32, but we are not checking for the specific prefix that we have in our chain. So here we'll have, well, if we have an error, we'll return this error, similar to this. And then we'll add an assertion that the bec32 account has the RPS chain prefix. So we're going to do strings as prefix, the address, and we have our params bec32 prefix, and in such case we will return an error as well. Here's strings, package strings, and here we'll have our invalid address. It's going to be the error. And we are going to say here invalid address prefix. Now that we have that, we can check that all tests are passing now. Let's run this keeper test suite. Make sure all test cases are passing. Let's see that we have some issues here. Expected. Seems that the expiration height is different because I may have used a different expiration height. Let's see. So we can see here that the only test case that's failing is the create game. And here we have the detail of what's the error. So yeah, it makes sense because the expiration height here I put 10, but if you remember the default one, the default TTL is 20. So we can go here to check this. The params, default TTL is 20. We can actually use this as types default TTL. That should work. We can try running again. And now all are passing. This is a run. You see create game successfully. It's passing. We have now only tested the message create game. Go ahead and add some tests for the message make move and the message reveal move, as well as the update params. I will add these tests later and we'll go through them real quick. Here I added the test cases for the message make move. As you can see, the setup is similar to the previous one. We have some addresses and the valid hash to move, and some test cases, some failing test cases. When there's an invalid game index, there's a game that has ended and somebody's trying to play, the invalid player that's not in the game, an invalid move, and then making a move successfully and checking that the state's transition is applied as expected. Then the message reveal move is very similar to the previous one, but we have to include the salt now. And again, we have some failing test cases and the reveal move successfully for different cases when the score is updating and when the score is updated and not. And then we have some edge test cases when the game ends with the last move, and we're validating all these state changes here. And the last one is the update params, where we just make sure that everything is working as expected. When the authority is not the valid one, when there's an invalid TTL setting when updating the params and updating successfully. Here, well, the default is 20, but we can change this to be 30. And yeah, that's it. Let's check that all tests are passing. Everything is fine. Let's push now these tests to our lesson 6. So you have it as reference, git add, git commit message, add message, server tests, git push, origin, lesson 6. In a similar way, you can add the corresponding test for the query server. So for the query server tests, I created the query server test.go, where we are testing the getGame function, and the test cases comprise all these fields: the name, the request, a validate function that will help us set up the test case if there's an expected error and which is the message, and the expected game. And I have here a failing case where there's a non-existent game, and a successful case where I use the validate function to create the game. And this is just the validation that everything is happening as expected. And then I have here some tests for the get params. We have a failing case and a successful case. So now I'm going to push these changes to our branch. We're going to call this add query server tests and push it to the lesson 6 branch. Now that we have unit test for our module, we have to write some end-to-end tests.